This lecture demonstrates two approaches to generating new variables. The two approaches use either the replace or the recode command. A general process to generating a new variable is simple. First, summarize the old source variable. Second, generate the new variable. And third, compare the new variable against the old variable for mistakes. Please do all three parts of this process and document your work in a data prep do file. I use the histogram and list commands to summarize and spot check continuous data before and after generating new variables. And I use the tabulate command to summarize and compare categorical variables. I will demonstrate all of these commands in this lecture. The replace command is more versatile than the recode command, but it requires more coding steps. There are 5 steps to using the replace statement. First, we generate a new variable and usually set it equal to missing. I say usually because there are times when I generate a new variable and immediately set all values to 0. But if this is your first time generating new variables, start by assigning values to missing so that you do not accidentally replace missing observations with the value 0. Second, we replace values in the new variable according to some condition. We can write multiple replace statements for each new category that we create. The next 3 steps relate to labeling. Third, we label the variable with a label var statement. Fourth, we create a list of category labels with a label define statement. We give this list a name, and the list exists in Stata, but it is not assigned to the variable until we specify a label value statement. These 5 steps relate to generation of a new variable and should be preceded by a summary of the old variable and followed by a comparison with the new variable to make sure we did not make a coding mistake. Creation of the data prep do file comes after development of a conceptual framework and before starting data analysis. In the data prep do file, we generate a variable for every factor identified in the conceptual framework for which we have data. As with all do files, we provide a descriptive header with the project title and purpose of the do file, name, and date. Then we open the original survey dataset, in this case the Rwanda 2000 Kids Recode file. I will first demonstrate how to generate a new categorical variable from an old continuous variable. In this example, we group mother's age into 3 age groups. To identify the variable for mother's age in the dataset, I use the look for command. Usually I do not document this step in the do file. I see that V012 is mother's age in years. Next, I explore that variable with codebook. I see that V012 is continuous, ranging from 15 to 49, with 0 missing values. Since it is a continuous variable, I check the distribution of values with a histogram and get a sense of the values by listing mother's age for the first 20 kids in the dataset. The histogram reveals that the age categories that we would like to use will work fine for this variable. There will be a sizable number of observations in each category. Remember, if there are too few observations in one category, the variable will not perform well as an explanatory variable in a regression analysis because there is little variability in its values. Next, we generate a new variable called age and set it equal to missing or dot for all observations. Then we write a replace statement for each of the 3 categories that we wish to create. Remember, our first category will identify all women who are age 15 to 24. We write replace age, the new variable, equals 1 if V012, the old variable, is greater or equal to 15 and V012 is less than or equal to 24. We use the same format to write code for the next 2 age categories. Then we label the new variable age with the text mother's age. Finally, we create a list called age_label with labels for each of the 3 categories and assign those labels to our new variable with the label value command. Let us run this code to make sure it works. It does. The output is black and not red. Now we check the accuracy of our code by comparing values in the old and the new variable with a list statement. When you list and compare values for only a few observations, you might miss a mistake. The most robust approach is to create a crosstab of the old variable V012 and the new variable age, checking that both numeric and missing values were correctly grouped. Let me stop for a moment to describe the operators that you can use to make powerful logic statements. Greater than, less than, greater than or equal to, less than or equal to, not equal to. These are all operators that you can use to assign values. Combine these with ampersand, the and symbol, pipe, the or symbol, and parentheses to develop logic statements. Sometimes new programmers are confused about when to use pipe versus ampersand. It helps to say the logic of the replace statement out loud. If you hear yourself say or any of the following, then use pipe. If you hear yourself saying and or all of the following, then use ampersand. Let me demonstrate the use of operators as we apply the replace command to two more scenarios. In the second scenario, we use replace to group multiple marriage status categories as married partnered and not married partnered. That is, we are going from an old categorical to a new categorical variable. Using the look for command, we identify V501 as the variable for marital status. The codebook command tells us that the variable is categorical, and it also lists the numerical values behind each of the category labels. We summarize the variable with a tabulate statement, and we include the option missing in case the variable has missing values. Now we are ready to generate a new variable using the 5 steps. First, we generate a new variable called married and set it equal to missing for all observations. Second, we replace married equals 0 if V501 equals 0, never in union, if V501 equals 3, widowed, if V501 equals 4, divorced, or if V501 equals 5, separated. Notice that we used or in this logic statement, which is why we use the pipe symbol. We use another replace statement to assign married to 1 if V05 equals 1, married, or 2, living with a partner. Then we label the variable and label each of its categories. Finally, we check our work by comparing the old variable V501 with the new variable married. In the output, old variable categories are on the left and new variable categories are across the top, and we see that mothers were correctly grouped in the new variable. In the third scenario, we will use the replace statement to combine two variables into one. The two old variables are employment status yes/no and type of earnings. We want to create a new variable with 3 categories: not employed, employed with in-kind or no compensation, and employed with cash income. We start by finding the DHS variables with the look for command and summarizing those variables with tabulate statements. We get the list of numerical category values behind the category labels with the codebook command. To generate the new variable, we start with a generate statement and call the new variable employee. Now we get to exercise the power of if logic statements. Our first category is easy to define. Replace employee equals 0 if V714, employment status, is equal to 0. Next, replace employee equals 1 if V714, employment status, is equal to 1, and V741, type of earnings, is equal to 0 not paid, or 3 in-kind only. Notice that I put parentheses around type of earnings because the ampersand before the parentheses refers to everything inside of the parentheses. The same type of logic can be applied to create the third category, and we label the variable in its categories. Finally, we compare the new variable to each of the old variables. In this first comparison, we are checking that mothers were assigned to the right employment status, and in the second comparison, we are checking that those mothers who were employed were assigned to the correct earnings category, which they are. The Recode statement is only useful when grouping old categorical variables into new categories, which is common in survey analysis. We already saw how to go from an old categorical variable to a new categorical variable in the married example using the replace statement. We will generate married to, the exact same variable, using the Recode statement instead, so that you can see that the Recode statement requires a lot less coding and only 2 steps. Before we look at the example though, let us review the syntax of the Recode statement. We type Recode, old variable, then generate new categories using a set of parentheses for each category. Inside each set of parentheses are four things: a list of all old variable category values with only spaces between the values, an equal sign, the new category variable, and the new category label, in double quotes. That's it. After defining all categories, write comma, generate, and give the name of the new variable in parentheses. The recode statement combines 4 of the 5 steps required for the replace command. Neat, huh? The only step remaining is to label the new variable with a label var statement. Now let us create the married variable using the recode statement. As before, we look at the category values of the old variable with codebook and summarize the old variable with a tabulate statement. Then we recode the old variable v501 and create 2 categories in parentheses. In the first category, we assign old values 0 and 3 through 5, ranges are indicated with a slash, to the new value 0, and we label this category no. In the second category, we reassign old values 1 and 2 to the new value 1, and we label it yes. At the end of the line, we generate the new variable married2. On the next line, we use the label var statement to assign the variable label. We can check our work with a tabulate statement, and to prove that replace and recode accomplish the same results, we can compare married and married2 and see that they are identical. If your research question is a general explanatory question with a format like, "What social economic factors are associated with child stunting?" then I strongly encourage you to make all of your analysis variables categorical, because categorical variables are much easier than continuous variables to interpret in logistic regression. If your research question is a hypothesis test question like, "Is mother's level of education associated with child stunting?" and you are testing a number of social, economic, or demographic characteristics as confounders, which means you will not interpret the odds ratios for these variables in the final model, then leave continuous variables like age as continuous. This will preserve variability in values and ultimately preserve more of the explanatory power of that variable. I recommend generating all variables for your analysis rather than using existing variables from the original dataset to ensure that you handle missing values appropriately and so that your variables and category labels are formatted as desired in your final tables later. Go to populationsurveyanalysis.com for a PDF version of this video and other learning materials that support your analysis of a population survey dataset.